I'm Joshua Bardwell, and if you've ever wondered how to wire up your flight controller, you're going to learn something today. Which flight controller? Which one am I going to teach you how to wire up? All of them. I'm going to teach you how to wire up all flight controllers. Stay tuned. A lot of the questions that people ask me boil down to this. How do I wire up my flight controller? A common manifestation of that question is people who don't know how to hook their receiver up. They don't know what UART, where do I wire it, and what do I need to do just to get it working. And I realized as I thought about these questions that there's a skill that people who are new to this hobby are missing. And there's no shame in that. This hobby requires so many different skills. You have to be good at electronics and computers and flying and building models. This is an incredibly demanding hobby, and that's why I do what I do, to try and help you get over that hump. The skill that I'm talking about, though, is the ability to read the pinout diagram of a circuit or a component and then apply that and some basic electronic knowledge to hook that circuit up and make it work. And this is something that people who are into electronics have learned, but many of us are not coming from an electronics background. So that's what I'm going to teach you how to do. I'm going to teach you how to read the documentation, read the pinout diagram for a flight controller, and then apply that knowledge to know how to hook things up. Because here's the thing. The flight controllers, they all are doing basically the same thing. You've got some ESCs, you've got a receiver, you've got a camera and a video transmitter, and it all gets hooked up, right? But there's a relatively small set of components that we need to hook up, and they're basically always the same. And so the connections that are going to your flight controller are usually going to be the same no matter what flight controller you're using. It's just a matter of figuring out which of those freaking pins and pads it needs to go to. And that's what I'm going to teach you how to do. Now, this is going to take more than one video. Okay, I'm not going to try and cram it all into 1 hour-long video. I'm going to space it out. So there's a playlist down in the video description if you want to watch the whole thing. But for now, let's get started on video 1 of this series. We're going to start by covering that fundamental knowledge that I said you needed, which is the pinout diagram. So a pinout diagram shows you all of the pins and pads on a component or a circuit board, and it labels them to tell you what they are. Each pin or pad is labeled with its function. I've got some examples of pinout diagrams here on the left. Most of these functions, as I said, are common to all flight controllers, so once you understand those functions, you can do the basic wiring of the flight controller with relative ease. How do you find the pinout diagram for a board? A lot of times the pinout diagram is going to be on the product page for the board, but what I always do is I go to my favorite search engine, which is Google. I enter the board name and pinout, and I search. And then I click over to image search and scroll through the results to find the pinout that matches my board. So here I am in Google, and let's just do Beta Flight F3. Oh, see, I've already searched it, pinout. All right, so there we go. And it's already giving me some suggested results. If I just go to the image search, then I can look for the pinout diagram. And you'll notice many of these are not the Betaflight F3. There's going to be a lot of garbage in here, but if you keep looking, oh, hang on, there we go. There's the pinout diagram for the Betaflight F3. You'll find the one you're looking for, and then you can proceed from there. Once you've got the pinout, the next thing to do is to start reading the pins and figuring out what they do. And that's what we're going to dive into next. The first thing you have to do is you have to power the board up. Now, some boards are powered from 5 volts, which means that you apply 5 volts to the board from an external voltage regulator that you provide. The external regulator is often part of a PDB or power distribution board. The PDB is used to connect the battery lead to the ESC power wires. So once a long time ago, you got the XT60 that you plug your battery into, and a long time ago people would build these wiring harnesses out of 12 gauge wire where the ESCs would solder directly to it, and there are many reasons why it's heavy, it's hassle to replace an ESC, etc., etc., etc. You can start to see why people used bullet connectors back in the day. Now we pretty much always use PDBs, which is a circuit board that you solder the ESCs and the battery to. And a lot of times those PDBs will also have voltage regulators built in. I'll show you an example a little later in the presentation. When a flight controller is powered by 5 volt, the flight controller will basically never contain an internal voltage regulator. So we need a voltage regulator to take the battery voltage down to 5 volts that the flight controller can use. The flight controller cannot run off of 12 or 18 volts or whatever it is your battery's at. That voltage regulator has to be somewhere. Sometimes it's built into the board. Sometimes it's on the PDB. On the boards that are powered from 5 volts, it will not be on the board because, of course, if the board had a voltage regulator, we wouldn't need to give it 5 volts. We could give it vBat. And that's the other kind of board that there is. So some boards are powered from vBat, which is shorthand for battery voltage. vBat is battery voltage. If you're flying 3S, vBat's going to be around 12 volts. If you're flying 4S, it's around 16 volts, and so on and so on. When you have a vBat powered board, you apply battery voltage directly to the board. And what that means is that you're going to solder your XT60 directly to the board if the board has a built-in PDB, or you may just need to solder a small wire to some pad on the board to power it externally. A vBat powered board, as I said, will have a built-in voltage regulator, and it's going to step down vBat to the 5 volts that the board uses internally. When vBat boards are connected to a battery, their 5-volt pads will have 5-volt power from their internal regulator. Now, some flight controllers will have a built-in PDB, and some will not. Flight controllers with a built-in PDB, that means that you're going to solder the XT60 connector and the ESCs directly to the flight controller. The first one to do this that I can think of was the Moto, not the Cyclone, the one from Moto, but I don't remember it. Wow, it was a long time ago. But these boards that have a built-in PDB are always vBat boards, right? Because you're giving the board battery voltage from the XT60 from the battery. So of course they're going to have a built-in regulator that they'll just power the board directly from there. Some flight controllers don't have a built-in PDB, and these can be either vBat or 5-volt boards. If you have a board that does not have a PDB, it may still have an internal regulator that allows you to give it vBat and power the 5-volt pads from there. But a lot of times the boards that don't have a built-in PDB are 5-volt boards, and you need an external regulator to power them. As I said earlier, the reason we need the voltage regulator is that these flight controllers cannot operate at 12 or 16 volts. The electronic chips and circuitry in there, it's designed to operate at a low voltage, and so in general you feed them 5 volts. And a voltage regulator takes the high voltage from the battery and steps it down to the lower voltage that the FC can use. Now, some builds will even have multiple regulators. So, for example, you may have a PDB with a voltage regulator on it. You may have a flight controller with a voltage regulator on it. And some video transmitters have voltage regulators on them to power the camera. You don't have to use just one voltage regulator. You can use multiple ones. And that's relevant because the voltage regulator will have a output capacity. So, for example, the voltage regulator on a video transmitter is only designed to power a camera, and it may only be rated for up to, say, 100 milliamps. That's not enough to power your whole copter, but it is enough to power just a camera. On the other hand, you may have a board like the Betaflight F3, which I believe has a 1.5 amp 5-volt regulator built in, and that may be enough to run the whole copter. You can sort of slice it up any way that makes sense. So now we're going to take a look at some example boards, and we're going to see which boards are vBat boards and which boards are 5-volt boards, and I want you to just expose you to this information so that you can get practiced at looking at the board and associating it with this information. So when you see a board that you've never seen before, you can make intelligent assumptions about how to wire it up. The Betaflight F3 board is a little bit unusual in that it uses the top and bottom. Now that's not so unusual, but one of the things it does is that it has the positive pad for the battery voltage on the top and the negative pad on the bottom. So here we've got the top side and the bottom side. And you can see that the top side has a plus next to it, that's positive, and the bottom side has ground. Sometimes a minus sign is used for ground, sometimes a G, or sometimes, as you see here, G and D. So this is where the big 12 gauge or 14 gauge battery wire coming from your XT60 would go, the negative one or the black one, and this is where the red one would go. You would solder them there. If we look at the pinout diagram, we can see that these pads are labeled LiPo plus 3S to 6S input. And this is another indicator that this is a vBat board. It's telling you that you're going to take your battery voltage, your LiPo voltage, the positive one goes here, and you can input 3S to 6S voltage. That's around 12 volts up to around 6S is like 22 volts or something. Okay, so it can take a 3S to 6S battery put right here. That's really important because if you put a 3S or 6S battery on a flight controller that's not designed for it, you will destroy it. So don't do that. Here's another example. This is the Holybro Kakute all in one, AIO. Now, there's another clue here that this is a vBat board and that you are safe to put battery voltage onto this board. The circuit diagram has the shape of an XT60 here and these great big pads are on the inside of it. This is designed to have an XT60 soldered directly to the board. But you'll notice also that it's labeled, it's a little small here, but it's labeled -B plus or -BAT plus. And we can see down here, BAT plus is input voltage, 7 to 42 volts. Well, that's a lot of volts. And G is ground. The minus here is indicating that this is the ground or negative black wire. The plus is indicating that this is the red positive wire. And also the shape of the XT60 would give that away if you weren't sure. So there's a lot of different pieces of information here that we can correlate to confirm our assumptions. Here's the Rotor Geeks SSD. Now this board is interesting because it is a vBat board. You do feed this board battery voltage, but it does not have a built-in PDB. So you are not going to solder your XT60, your main battery lead, directly to this board. You're going to need an external PDB. But you can power the board directly off of vBat, and it does have a built-in regulator. And the idea behind this board is that you can wire all kinds of accessories like an LED strip or your receiver or your whatever else you want to run, whatever 5-volt accessories you want to run can be wired direct to this board. And I don't know, keeps your wiring simple or whatever. So you feed the board battery input here. We can see it's labeled -BAT plus, and it says battery input 2S to 6S. That's your indication that you power this board by feeding it battery voltage. So in this case, what you would do is obviously these pads are way too small for a big 12 gauge or 14 gauge wire like you might use for your main battery lead. You would have a small wire like a servo wire around say 22 or maybe even 26 gauge, and you would wire it to the vBat pads on your PDB. Or you could even wire it directly to the main battery pads if that's what was convenient. But most PDBs will have a separate set of vBat pads that you can use for an accessory like this. We'll see an example of that in a little bit. Here's the Luminaire Lux V2, and we've got two pads here labeled ground, or G, and BAT. G obviously is for vBat ground, the black wire, and plus is for vBat positive, or the red wire. Oh, sorry, that's not plus, it's BAT. It says BAT here. This is a little bit confusing. I would want to confirm this with the manual before I wired it up. BAT, I don't know, especially because it's a small pad. This again is a board without a built-in PDB. So with a board with a built-in PDB, there's usually a great big honking positive pad that really is just very clear that that's where your battery goes. But in a board like this, I would probably want to double check against the manual that that's exactly where vBat's supposed to be. But in fact, it is. You power this board by putting vBat here and of course negative or ground here. Here's another one, the Furious FPV Radiance. This one is also a vBat board. We can see here it says BAT plus and BAT minus here. And you're going to wire that with a small 22 or 26 gauge wire to the battery voltage on your PDB. I realize that I'm showing you a lot of examples here. I hope I'm not boring you, but I want all these boards look different. But what I want you to see is that the same information is there. It's not presented in the same way, but it's exactly the same information. These boards are not really actually that unique. The designers of the boards are upset with me right now. They're very unique. Every one of them is special and distinct and deserves its own attention. But they have the same set of features. It's like if you get into a car, right? At the end of the day, you're going to turn the wheel, you're going to press the gas, you're going to press the brake. You don't need a separate instruction manual to drive every single car you get into. And likewise with these boards, they have these common features. And I just want to show you a bunch of different examples of that so you can start to pick up on the patterns. An important thing to know is that all of the 5-volt and all of the ground pads on these boards are shared with each other. Electrically, they are in parallel. Now, if it's not obvious to you what that means, what it means, it's like this manifold, this garden hose manifold. So you put the garden hose in here and the water comes out there, right? But if you were to put some water in here, it's going to come out all of these equally. Which of these should you put your garden hose on? Well, it doesn't matter. You put your garden hose on any of them. You put your garden hose on all of them, right? As many hoses as you want to plug into this manifold, you can plug them in. They're all going to get water. And that's what the 5-volt and the ground pads are like. So in fact, when you're trying to power something like your receiver with 5 volts, it doesn't matter which 5-volt pad you use. If we're going to get to wiring up the receiver in a bit, but for example, you might wire your receiver to this RX pad here, right? And you say, well, I got to use this 5-volt pad right here that's right next to it. And in fact, that's why that 5-volt pad is there, for convenience of wiring it up neatly. But if you wanted for some reason to wire it to this 5-volt pad all the way over on the other side of the board, they're absolutely equivalent in every single way. And likewise for the ground pads. They are placed next to the thing that you're going to be soldering to for convenience and neat wiring. But in fact, all of the 5-volt and all of the ground pads are completely interchangeable with each other. And I tell you that because we're going to look at this board here, and this is an SP Racing F3. Now, this is a board that does not have an internal voltage regulator. You cannot feed this board vBat. It doesn't have a PDB. It doesn't have any of that stuff on board, which means you're going to need a 5-volt regulator, and you're going to need to give it 5 volts somewhere. Where? Well, actually, it doesn't matter because of what I told you on the last slide. All of the 5-volt pads are absolutely interchangeable. So you may connect 5 volts to any of the 5-volt pads on the board. And a common way of doing that is the motor headers here. So this is the motor header on the board. The SP Racing F3 supports up to 8 motors, so it could do an octocopter if you wanted. Most modern boards will have either 6 or 4. They often are doing just 4 nowadays. Sometimes they'll do 6, and sometimes they'll do 4, and then they'll have 2 other little small ones somewhere for 5 and 6 if you really want them. But few of them have 8. So this is actually a little bit of an older style of design that we don't see as much nowadays. There's a reason why this presentation I've shown you like 5 boards that have a PDB built in and a vBat, and like I couldn't really find very many modern boards that don't have a voltage regulator on board. But the SP Racing F3 doesn't, and you're going to power it. The way this header works is you've got ground right here, and a good tip. Hey, here's a good tip. When you've got a row of headers like this on a board, usually ground is the one that is closest to the edge of the board. That's a design convention that board designers usually use. Don't assume, always double check with your multimeter, but ground is usually the one that is closest to the edge of the board. So here's ground. Here is for the signal wire. These are the motor outputs going to the ESCs. And then this middle one is for 5 volts. It's only labeled with a plus, but it is not vBat plus. That's just a convention you need to understand. When you just see a plus, you got to figure out, is it vBat positive or is it 5-volt positive? You have to just look at the board and figure out from context. For example, if it's a PDB and it's an output to an ESC, then that's obviously vBat. The ESCs don't take 5 volts, they take vBat. On the other hand, if it's your receiver, then it's 5 volts. Now, the reason these plus pads are here is that way back in the day before we had PDBs, one way that we would power our copters is that the ESC would have, say it with me, a BEC. What's a BEC? A BEC is another name for a voltage regulator. Why didn't they call them voltage regulators? I don't know. Well, I do know, but it doesn't matter. They call them BECs, and the ESC would have a BEC built in, and the ESC would provide 5-volt power on the middle wire of the servo connection, which wasn't being used for anything else. So this is how you would power the flight controller. And if you have a flight controller like this with no onboard voltage regulator, you're going to connect 5 volts. The most easiest thing to do is to pick one of the motor headers. These pins are not going to be used for anything because these days we usually don't power our flight controllers. Our ESCs are usually, they do not have a BEC or voltage regulator on board. We're going to use a voltage regulator on a separate PDB. It turns out the voltage regulators in the ESCs were usually not that great. They had a habit of browning out, and it's better to get a PDB with a good, solid, quality voltage regulator to power your system, and this is where you're going to wire it to. Now let's take a look at some PDBs because I want to give you some perspective there. I've been talking about, you're going to wire up your flight controller to your PDB. So here are a couple of PDBs, and if we look here, we can see that the PDB is always designed to have the XT60 running to it. So PDB is always going to have 2 great big pads that are designed for the 12 or 14 gauge wire that you're using for your battery lead. And if we look at these 2 PDBs, we can see this one is labeled BAT, and here's minus and plus. So this is where the red wire is going to go from your XT60. This is where the black wire is going to go from your XT60. I'll look over here. We see BAT, minus, and plus. Same deal. Then we can also see here is a 5-volt output. And this is the 5-volt pad that you would solder the wire to that would then go to one of these pads. And that's how your flight controller would get its 5 volts power. Over here, we've got plus 5 volts minus right here. That's 5-volt output as well. And that is going to bring us to the end of this video. I know for many of you, this video was extremely elementary and you probably tuned out and stopped watching. But I also know that many of you out there have never, even if you've built a quad, some of you have still never really thought about this stuff to understand why you're doing the things you're doing. And I hope that I can continue to help you do that till you get to the point where if I were to hand you a flight controller that you'd never seen before with no documentation, just by looking at the silkscreen labels on it, that you could figure out how to wire it up. It is absolutely possible to do that. These flight controllers there's nothing new under the sun. They're all doing the same thing they've done for the last 3 years, more or less. And when you get to the end of this series, I hope that that's the state you'll be in. For now, I hope this was educational. And as always, happy flying.